My phone, just because I didn't wanna wait until I got to the laptop to actually do that. I think I've come to peace with these. Thanks, Craig, for all the help by putting the comments in the last videos and also via Twitter. My ultimate goal was trying to find an explanation of sort of a definition of that operation, the control X node, that would be that would not use interference, that would not use the Hadamarts, because it's just to kind of have a useful construct, or a sort of a concise way to define that operation. The beauty and the problem at the same time of my current understanding of quantum computing is that the way the operations, the way certain gates and gate combinations are used, can be really mind-bending and can be used to do really interesting stuff. So I basically I boil down the definition of this in the following way. So and kind of, I think from the very beginning that was really not it was really not far away from what I had in mind. I just was not feeling good with it. But let's start with the definition, or because I will do that analogous to the control Z. So you've got here your qubits, right? So what you do with the control Z, is basically you want to. So you're saying if I have, so you're saying you want to negate, you want to phase, or you want to phase your system based on a pattern. Like, so if this is this circle and then that, so you want to basically change the phase when the when the state matches 0 1, right? Because this is this would be, it's an empty circle. So, and you can see here the phase is 0, right? So, and if I do that, now the phase is actually changed to 180 degrees because it matches the pattern. If I do that, the phase is back to 0, right? So you see, and this is basically what this is kind of doing. So if you are in a state in which it is not just a single state, you're gonna flag that portion of it. So if you have, like, say, but it's not that straightforward to kind of see, but here you see that, and that because the second component is so here you have a 0 1, it's actually flagged, it has a 180 degrees. So the way that I now, based on this, define this operation, about 0, is in a similar way. So what this is going to do is this is going to phase a superposition that is created with that particular pattern. So it's sort of analogous to what the control Z does, right? So if you've got a 1 1 and you want to flag a 1 1, then you've got to use a control Z. So in this case, if you've got a superposition that is created with a 1 1, right? So now you create superposition. And now first let's take a look at how this looks like, and then we apply that operation. You see that it just negates everything. That's basically, in using nice words, what Craig was saying by taking a look at what happens when you put Hadamarts around the displays, and by the fact that you take from, if you speak technically, but this is still super up. It still bends. It still hurts my mind a little bit to try to imagine that or think about that. Maybe because I tend to try to visualize things and that hurts me. But it's basically taking the projection of your state on the x-axis, negating that projection, and then adding it again into your superposition. But I kind of, I think one intuitive way to define that is, it's basically sort of you could think of it as a superposition recognizer, kind of. So it kind of recognizes a superposition that's created with a 1 1, kind of. If you think this 1 1 being the seat of your superposition, this is what it's doing. So if I change these for the -1, right? So now now you can see that it didn't change. So what this is doing now is the reason it didn't change is because that doesn't match the seed of the superposition. So if I go to 0 here, right, now we see that it actually works. So it actually flips, it negates the superposition. So and then based on the same definition works for the y controlled operation, so for the y-axis. So if I now do these and these, right, but this works on complex uncertainties and complex superpositions. I mean, I don't know if that's the right way of call them, but that's the way that I like to think about them. Is let's see if I can. So how would I construct one? So I would say, because that's a bit, okay. So yeah, that's actually I, and that's so useful. You can do that. So it's actually yeah, that's it. That's it. Of course, it's I. So yeah, so that's the type of. No, wait a second. I'm doing this. It's minus I. I forgot to remove the outer marks. And now minus I. Correct. So and that's that you're kind of recognizing that pattern, right? So these are sort of filters in that sense. That operate with uncertainty, so it kind of filters uncertainty, and I think I kind of like that concept a lot. Maybe it's really just worthless to go in this direction, but I think I'd like to sort of put the brakes on some of the other open videos and open topics that I have, and I'm kind of thinking about sort of delving a little bit more into these positive like real uncertainty, so positive negative uncertainty, and then having also this complex uncertainty thing with the y-axis, and kind of play around with it a little bit more. I actually have a playlist with be more like exploratory stuff, and maybe I'll just play with this, see what other things can we do with that, try to solve some problems. I don't know. I feel it's a nice area that I like to explore, and maybe it's just, I don't get anything out of it, but I kind of feel a bit bored right now with all the other machine learning stuff. And I think this is definitely an interesting, so and that kind of makes me the way this is used in Grover's algorithm implementation is a bit tricky, right? And kind of you have to have that leap of faith of saying, good, so if you've got a superposition, right, that has a 1-1 seed, and basically what you're doing now is you're hijacking that, so you're distorting one portion of it, so you're basically moving the needle, right? So you're saying, no, for the state 1-1, I'll flip the phase. So now the trick here is that when it's almost like if your filter would have a hole. That's an awful it's an awful analogy, but it's like when if you now try to apply this operation, what happens is that your uncertainty kind of tends to go back to that particular state that you flagged, but and that kind of works. That works only when you have a control set. If you don't have that, like, that doesn't work at all. So it doesn't really play. It kind of. I see. Okay. It kind of touches again the. So what does it do? It touches. It actually changes this amplitude and this amplitude again, and that's it, right? This is a bit more tricky to explain, and I think I won't open up that box for now. The way that I like to think about it is the fact that you've broken sort of the equilibrium, right? So you've broken the equilibrium. So here you would basically negate that superposition, but because you flipped one of the phases. when you're now trying to change that, um, it basically goes into that, you're kind of creating an imbalance and it goes there, so it accumulates there. That might be far away from a technically correct explanation, but it just, I'm trying to build higher level constructs for myself, to kind of, um, I mean, I don't know really why I'm even doing that, but it's like, it feels it's an easy way to then maybe use those, use those constructs to understand, a bit better what you're doing, figuring out other things you can do. But I mean, the explanation from a technical perspective, it's these, right? It just becomes complicated to explain the effects when you've got weird inputs, because what it's the same as if you even forget that and then say like, what happens if if you're having, now suddenly you have that seed, right? And then, your filter is acting weirdly as well again. uh, yeah, it's not it's interesting. Yeah, because in this case you can really think of this being negated, right? But it's not really what's happening. So I think in its most pure definition, that's what I like to think, because it matches the definition of the control set. It acts almost like a filter, right? So it filters a certain pattern. And in this case, we're talking about the seeds of a superposition. It just flips that. But if you mess, if it doesn't work if if you if you have, that's interesting enough. So if you've got other combinations of zeros and ones, it just doesn't work. Will be interesting to see what happens with other combinations. That's what I probably want to explore. I think that can be, maybe there's something interesting to explore in there. We'll see. Yeah, but basically that's the idea. So stay tuned for more videos on this. I'll be exploring those concepts a bit farther, just by randomly playing with it. I was even thinking about extending Quirk at some point to add the color coding for the phases when you have more like bigger displays. It becomes a bit tricky to see what's plus and what's minus, or what's like 0 degrees and 180 degrees. But we'll see. Cool.